Hello, everybody. So my name is Patrycja Cieplicka, and I'm an NLP and LLM engineer in Tuplux. And today I will talk about how we evaluate large language models. So just a short introduction of the Tuplux company. Oh, sorry. Okay, so Tuplux is a software company that is mostly focusing on customized AI solution for the clients. And we are mostly focusing on the computer vision things, but of course we also extend our knowledge to LLMs, data science, VLMs. And I'm working mostly on the LLMs for the e-commerce client. And we are pretty integrated with the client's team. And what we are doing is, our team is doing adaptation, so we are doing post-training, fine-tuning, LoRa, also prompt optimization, so many different things for the e-commerce domain. Then we are also evaluating models, so general models in e-commerce domain, how they are doing, but also for the use cases, also we are doing evaluation. And the last one is LLM optimization, so we are also looking at the inference, cost, deployment, tuning, those things. And today I will talk only about the LLM evaluation because this is the thing that I'm most contributing. So we can, I think, divide 4 different metrics for measuring LLM's performance. And first one is, I would say, traditional metrics, like the exact match, blue, rouge, bird score, also regex, verifiers, all of the functions that we are using, and also log probability-based metrics, perplexity, log props. Log props, we are using them mostly for the multi-choice benchmarks, and those two are, I would say, code-based metrics. Then we have LLM-as-a-Judge, when we are using another LLMs to score predictions. And the last one is human evaluation. So when we are asking human to scores the predictions, but also LLM's leaderboards when we are ranking the models, which is better. And each of this group has its own pros and cons. So for the traditional metrics and for the log probability-based metrics, so those code-based metrics, they are fast, cheap, and reproducible. That's a good thing, but they are only good for the closed form tasks. And especially for the log probability, it's good for the multi-choice tasks, which are not really used in the real world, right? We are not asking LLMs to answer A, B, C, D. And then we have LLM-as-a-Judge, which is easy to scale. Also, we can use them for the free-form answers, so for more complex evaluations. But it requires a lot of effort to set up this correctly. When we start to scale the solution, it can be slow and very expensive. And sometimes it can also be not reproducible if we set up this in the wrong way. And the human evaluation, the last one, is the most trustworthy, but of course expensive, slow, and low scalability. And first, I will talk a little bit about open source benchmarks. So I was mostly in my work I was evaluating general models. That's why we were using those open source benchmarks. But also I think that it's good when we are starting to look at the models that we can use for our specific use cases. It's good to see how they are behaving on the open source benchmarks. And what we are doing is first to group open source benchmarks into particular capabilities, for example, knowledge recall, instruction following, or code. And we are using for the evaluation only those benchmarks that we believe that this capability is important for our use cases. So if, for example, we are generating item titles, probably it's not for us important that the model is good at coding. The other thing that I would like to talk to you about, open source benchmarks, and the general models and the reports. So first one, we need to know that when the model it come up with some results, with some cards. We need to know that very often it is overfitted on those benchmarks. So like we need to be aware of that maybe the training data was in part, like in the evaluation data, we don't know this, right? So we need to be aware that it can be like that, and maybe this number is not really reliable. So we need to be aware of that. And the second thing is that, sometimes when we have like a model A and model B and they are reporting like the same metric, sometimes it cannot be comparable because when we look at the specific environment setup for the evaluation, we will see that it was different. For example, for the GSM metrics, when you look at, for example, LM harness package, you can see there are different prompt templates for and how you can evaluate on this particular task the model. So if, for example, one model is using original template, the second model is using another template, and they are providing the results, those two numbers are not comparable. So we need to be also aware that and we need to check the environmental setup for the evaluation to be sure that we can compare in reliable way those two metrics. Another thing that I would like to talk about is statistical significance, because this is something that I rarely see, even in the papers. So we have, for example, model A, model B. The accuracy is similar, but one is probably better. And we, as a human, thinks that, model A is better. But I think that the answer should be that we do not know if the difference is significant, and we need to check it. So as I said, often we treat small metric differences as a real improvements, but that could be just like a random variation due to sampling, due to non-deterministic kernels, and so on, prompt randomness. So it's good to do a simple statistical check. For example, per t-text, some Wilcoxon text, or bootstrap resampling. And now we will go to our own evaluation, because of course, if we have our own LLM applications, we would need to design our own evaluations. Public benchmarks probably are not enough. And there are core evaluation principles. So first one, avoid training data in evaluation set. I think that it's rather known that we shouldn't do this. But if we are using public data, sometimes we do not know if in this public data there are no data leakage. So it's good to filter out the samples that are similar to our training data or even the same. So it's good to do this with the public data because with our internal data we have more control on that. Second thing is use deterministic metrics when possible. So I mean that those code-based metrics. Of course, there are some aspects when we cannot use those code-based metrics and we need to use as a judge. But it's better to use this only when it's needed. So for example, when we want to check the length of the LLM answer, do not do this with the LLM, right? It's just a quick function that is, calculating the number of tokens. So that's a good thing to use as a judge only when needed, and other things should be done with the code-based metrics because it's cheaper, it's faster, and it's more reproducible. And the last one is ensuring that the test sets reflect real-world data. And I think that to be sure that it's like that, it's iterative process. So we are starting with the small number of samples, and then we are increasing this, and this evaluation data becomes more representative of the real-world data. And I would like to propose, I would say, evaluation-driven development for LLMs when the evaluation development and model development comes in parallel. Even when we are starting the project, we start from evaluation, not the model development. And what are the pros of that approach? Is that first, when we are working on the evaluation, we start to think what are the requirements, and it's easier to align with the stakeholders what really you want to achieve with the model. That's the first thing. And the second thing, when we are doing this in parallel, like the iterative working and checking if the model improves or not is much more easier and faster. Yeah, so for the iterative approach. Imagine that we're designing like evaluation with code-based metrics and with the LLM as a judge. So we are starting with defining evaluation scenario. And then we are preparing test sets. But like on this point, I'm not talking about preparing evaluation set for the model that we will be evaluating, but I'm talking about test set for our evaluator, for our LLM as a judge. So if we are using LLM as a judge in evaluation, we are building LLM application. So we need to evaluate it also. So our evaluation system needs its own evaluation. And yeah, so we are preparing test set for our evaluation, and then we need to label it with the human scoring. And I think that this is important, that it needs to be done by the human, not by the LLM itself. And when we have like this test set with scoring from human, then we can go to the evaluation tuning. So, creating model prompts for the evaluation, prompt engineering, and those things. And then we can go to the evaluation validation and to see how our current prompt is correlated with the human scoring. And with that, we see how accurate our evaluator is. And based on that, we can iterate to have like almost 100% of agreement with the human scoring. That's the goal of doing this loop. And there is also one thing that I read in some paper. It was called like criterion drift. I think that it was in the paper Who Validates Validators. And they are mentioning about this thing that, of course, when humans are scoring LLM's output, they need some criteria to do this, but also during the scoring, they are changing the criteria for the evaluation because it's much more easier for them to find out what is really, really important for that model. And it's easier to change the evaluation prompt for the right direction to be more accurate with the human scoring. And also to, they are finding some aspects that are only specified for those models that can be managed with the evaluation prompt. And then we are going to evaluator deployment. And after this, we can wait our LLM application, but on this full evaluation set. And of course, in the meantime, we can work on our LLM application development. So when we are changing the model, probably we will also get new production data. We can add this to our evaluation set, and then we are going this loop one more time. So it is an iterative process, and evaluation should evolve together with the model and with the solution that we are doing. And now we are going to LLM as a judge, because I said it's not so easy to set up LLM as a judge evaluation in correct way. And we have different comparison methods. It's scoring, so we are asking models to score the answers, for example, between 1, 5, 1, 10. That's one approach. And second approach is pairwise comparison, so we are asking a model to say which of the output is better, response A or response B. And both of those comparison methods work with or without reference answer. So the grant true, it's just, we can add this to both of those comparison methods. And now I will go for some best practices when we are designing prompts for the LLM as a judge and how to do it in a good way. So first of all, we need to evaluate across multiple dimensions. So it's not that that one prompt will be good for everything. it's rather not enough. We need to look at the problem from different directions to catch up when the model is not doing great. That's the first thing. Second thing is that it's better to have 3-4 independent prompts rather to have one complex prompt with some complex criteria. So it's easier for the LLM to work on simpler tasks rather than a very complex one. So if we have, for example, prompt for hallucination, prompt for correctness, or something like that, it's better to have those as an independent evaluators rather to have this in one prompt and asking LLM for scoring in those 3 dimensions. Next one is that it's good to use binary or low granularity score. So for example, making a scale from 0 to 100 for the LLM, it's not so good. It's rather it's better to have, for example, 3, 4, 5 scores, and it needs to be clearly defined what does it mean, right? Because if you will just say for the LLM that score this answer between 1 and 5, then what does it mean that it's 3? We don't know this. So we need to clarify and clearly define in our prompt what does it mean that the score is 1, what does it mean that the score is 2. Oh, sorry. Some technical, okay, it came back. Okay. Then another tip is that it's good to ask the model to justify the score, and it's good for debugging, good to validate if the judge is working how we want. And then another tip that it's good to use structured outputs because it enforces a fixed output format. It's better for parsing and for analysis. And then also it's good to include few-shot examples. So we are providing the models with different examples how to behave in a particular situation. And it's good to have a bad and a good examples. And also encourage the model for the step-by-step reasoning. That can also help. We also need to be aware of the common biases. That, for example, position biases, that sometimes LLMs are choosing just the first answer, that there are papers that are claiming that, for example, models likes better longer responses, even if they are not more correct, I would say. And also self-enhancement biases that, model will, when we are using the same model as a judge and we are judging the same model for the judge and for the evaluated model, then probably it will also choose the same model, right? So we should use independent judge. So for example, if we are evaluating, llama models, it's better to use GPT, Cloud, and so on models for scoring. Or even it's better to apply multi-judges. So we have 3 or 4 or even 2 different judges from different models family. The next one is temperature, 0 for evaluation. So we do not want to be as a judge to be creative. We want them to be reproducible. That's why this temperature 0 is very important. And the last one, we need to consider time and cost constraints. In the end, if the solution will be scaled and will go to production. Because LLM-as-a-Judge, especially if we are using APIs from OpenAI or other models, it can be expensive. So we need to be aware of that. Okay, so coming to an end, as a final conclusion, I would say that the most important is that, of course, the evaluation should be robust, should be reproducible, but even the most ideal benchmark has little value if it's too complex or just too costly to run. So we need to remember about this at the end, and sometimes better is the enemy of good, and we need to, in the end, focus on the business impact, not the perfection of our evaluation benchmarks. Some research resources, and that's all. So thank you.
Right. Questions, right? Lovely.
Hi, thank you for your presentation and thank you for proposing evaluation-driven development. This is great. We had a presentation from Piotr and Wojtek about how important it's to talk to users, to the customers. And my question is there any space in the current LLM evaluations frameworks that sort of incorporates feedback from users, whether this is, like, dislike, or different types of human feedback, basically?
I think that yes, from the open source, I would say, frameworks that I was working with, there is something like Anxious. And then you can connect this with your application, and then you can look at the traces of the users. And of course, the human can vote if this is a good or not good answer. And I think that this is really great to add this data to your evaluation datasets to have a real data, because at the beginning probably we are starting with the synthetical data because we do not have real data, but when the application is go to production, we need to have this real data, and it's good to have this and monitor what's going on.
Yeah, thank you very much for the presentation. You said that you worked with some e-commerce companies. So my question is, which areas of e-commerce businesses has the most impactful result of integrating LLMs into it? So if you have something to say about it, I would like to hear.
So for the client that I'm working, the models that we are developing and evaluation, it's mostly in this content generation area. So generating titles, generating descriptions, and those things. And yeah, in this content generation area, evaluation is pretty complicated because it's not closed form, it's not map, it's not code, it's not so easy to evaluate this in the right way. That's why the evaluation is so important for that area.
All right, any more questions? Yeah, that's it. Thank you very much.
Thank you.